have hydrocarbons as our simplest organic molecules. Okay, hopefully you remember what molecules are. What are molecules? What's a molecule?
Two or more elements?
It is a substance. It is two or more atoms bonded. But
They're
what
distinct
else?
particles?
Yes, well, I would probably call them like discrete
Yeah.
or but distinct is fine. Okay, they have a particular arrangement of those atoms. It's the same every time, and there's a beginning and an end to them. Remember our ionic compounds? They can form as large a crystal as ions are present. That can't happen with a molecule. So, for example, our water molecule, that's it. It's never going to get any bigger than that, or smaller, and still be a water molecule. Okay, so they are discrete particles. And I'm going to change whiteboard markers. For our hydrocarbons, they can be saturated or unsaturated. Do you remember what those words mean in the context of organic chemistry?
Like all the carbon, or all the atoms are like filled up. Like they can't add more.
Can't add more hydrogens. Yep. So for our, probably the easy way to think of it or to explain it, all single bonds. We're talking here about carbons. Because hydrogen can only make one bond, can't it? So, for example, something like this. What's its name?
Propane.
Thank you. Now, we're in big school. We don't have to draw out hydrogens anymore. So we can just put the stick there for the bond, and a stick with nothing written on the end is implied then to be a hydrogen. Because we have to write bigger, more complex molecules, we're not going to waste time writing hydrogens on it. So if saturated are all single bonds, what's unsaturated?
At least one bond.
Yes. So what's this? Ethene. What about this one? Oh, I left the carbon out.
Hence.
One hole.
Yeah, yeah. So here we've introduced, or we've come across something that needs a number. This one didn't need any numbering, this one didn't need any numbering either, because there was nothing to number. In this one there was only one place where that double bond could be. But now if we've moved into a place where there are other possible isomers, then we need to number. Okay, so what's an isomer? Just used a word there that
A variation. formula.
Okay, so isomers,
The same chemicals formula, but different structure.
we'd actually call it, yep, molecular formula, but that is right. Yep, okay, so our isomers have the same molecular formula, but the bonds are different, depending on what we're starting with. Let me have a look at naming. How do we name? What process do we do? What's the first thing that we have to do?
How many carbons?
First thing is to determine the number of carbons in the longest chain. And I rub out a bit up the top here. Can maybe put something on there as an example. Alrighty, this one's not too hard. To find the longest chain, how I would recommend you find the longest chain is you draw a sausage around it. And you count how many carbons are in there. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we look at our formula sheets. Well, what's that going to be? Sorry? 9. 9 for 9. We need to make sure that our longest chain includes the double or triple bonds that are present. Okay, which we've done. Our double bond is in there. And our second step is to number the carbons in the chain. Now, we have a choice of numbering, don't we? We could number right to left or left to right. So that's left to right. That's numbering from right to left. Now, we have some rules as to which way we have to number based on what's present, and the double bonding here means that I have to number to make it the smallest number possible. So I am going to need to number left to right. we don't have any double or triple bonds present in our chain, then we're trying to make our side chains have the lowest possible number. Okay, so we're now up to non-2-ene, aren't we? Because it's an alkene, it's going to end in ene because it has a double bond. It's off the second carbon. Now we need to identify all our side chains. And similar to the sausage, I'm just going to go along and draw a circle around them. The reason why you do this is because sometimes it can get a bit cluttered and it's easy to miss, especially a fluorine, because the F, the F looks a fair bit like the H if you just at a casual glance. But if you go back and you have a look around and you make sure that everything's only a hydrogen, then you've found everything. Now our carbons have already been numbered. We can't change the numbers now, and so once we've identified all our side chains, the next thing is to list them alphabetically. So what's this one called? Methyl. What's this one called?
Ethyl.
Ethyl. And bromo. And chloro. So which one's first in the alphabet? Bromo. So it's going to be 7-bromo. We already decided that it was the 7th carbon. What's next? Chloro, 8-chloro. Then ethyl, 5-ethyl. 6-methyl. Non-2-ene. Okay, so this is the process that we need to go through in order to name our hydrocarbon. Sometimes we might have multiples. And in which case we might need to use di or tri or tetra, which also would go in front. So, for example, if we had, say we have another bromo there, then that would be 7,7-dibromo, and everything else the same. Yeah? Okay. So I want you to have a little bit of a go at some of these questions. If there's something that I haven't covered that you want some more reminders about, then let me know and we can do that as well. This is trying to just get you back in that